the 11th of September 2002, a mere 18 months after the start of construction, the maglev carriages were mounted on the guideways, and the trial run began. This was a necessary step before the public could ride the maglev from downtown to the airport. With the pomp and ceremony behind them, it was now time for the engineers to prove that the concept worked. The German and Chinese construction teams came from different engineering traditions and systems. Would they have managed to overcome the problems of time and distance and execute design specs with system tolerances of less than 2 millimeters? The guideways in Shanghai were an adaptation of the German-engineered version. Instead of building a 50-meter-long guideway beam, the Chinese engineers cut that in half and used 25-meter girders instead. This doubled the work and the number of guideway beams required for the 30-kilometer stretch, but it made it easier to transport and assemble the spans, and meant that the Chinese team was able to meet the construction deadline. Even for the experts, this was a technical marvel.
In Shanghai, you've got a 19-mile-long guideway system that is built to within 1 millimeter tolerance through its entire length. And to my knowledge, there's nothing in the world that comes as close to that level of precision.
To keep the guideway within the strict operating specifications, engineers used an adjustable bearing system which allowed them to correct the guideways if they settled. The three-way bearing system raised or lowered the guideway beam to adjust for settling. There were more than 10,000 adjustable bearings along the entire route. But not all the guideway sections were rigid pieces of concrete. Some were made of steel. These steel switches could be bent on command, allowing the train to change guideways. But the speed was limited to 200 kilometers per hour in the curves. The problem was the human passengers. A sudden change in direction at high speed would throw passengers around. With the guideway virtually perfect and the first maglev vehicle safely mounted, a test run was performed with a single train. In the speed trials, engineers got it up to 501 kilometers an hour and established a new world record for commercial rail systems. But they had one more hurdle to face. There were two guideways running side by side. They now had to run two vehicles past each other. The trains would pass in close proximity at a combined speed of 860 kilometers per hour. Based on simulations and research, the vehicles were designed and built to survive high-pressure wind effects as they passed each other at full speed. But an actual passing test had never been done before. The engineers couldn't sign off for public use until this test was completed. One left from the Longyang Road station downtown and the other from the Shanghai Airport station. In just over 3.5 minutes, they'd reached the halfway point on the line where the vehicles would pass. Each accelerated to a top velocity of 430 kilometers an hour and would sustain this velocity for less than a minute. At a combined speed of 860 kilometers an hour, the maglevs passed each other. It was a major success for the team. The maglevs survived this critical trial run intact. Now just one question remained: would people pay to use it? The Chinese flocked to this new system, and within 3 years, 8 million passengers had ridden the Shanghai maglev.
It's truly a phenomenal transportation mode, and it's the reliability aspect of it that I'm most impressed with. It's 19 miles apart. The trip's about 7 minutes and 30 seconds. But the vehicles leave and arrive on time to the second 99.92% of the time. That's phenomenal. I mean, that's almost too perfect. People aren't going